afternoon, good evening, whatever the case may be. We are back in better than ever, better than ever. A little bit of a stumble over the words there. We are talking about sign diagrams. Let's get to it, shall we? Okay. So sign diagrams are able to tell us fairly quickly where a function has positive values and where it has negative values. So you see these little minus, plus, minus, plus, minus, plus. It shows the intervals where the function is positive and where it was negative. Very, very powerful, especially when we get into applications. So here we go. Let's see, for the function f of x, the sign diagram consists. These are things where what we are looking for. Horizontal line, which is the x-axis, positive and negative signs, which we just showed you, the zeros of the function, we're going to have to find the zeros, and also where the graph is undefined. Okay, so that's what we're looking for. Here is a function, y equals x plus 2 times x minus 1. And this is how we're going to use them. And don't worry, I am going to go through this step by step. But you should be able to clearly see the zeros of this function are at -2 and 1, which correspond to the sign diagram down here. We write down where the zeros are at 1 and at -2. And then to the left of -2, the function is positive. And you can see that graphically because it's above the x-axis. All positive values for the function. Remember, the value of the function is equal to its y coordinate, okay, with its corresponding value of x. Here, between -2 and 1, you can see that the function, or the graph of the function, is below the x-axis, indicating all negative values from -2 to 1, and then, again, all positive values to the right of 1. Same idea here. I'm not going to go through it. Here, we don't have any zeros, but we do have a place where the function is undefined, and that's when x is equal to 0. We cannot divide by 0. So that becomes what I'll sometimes refer to as a critical point. We do some testing, which I'm going to show you, and you can see that the function here is or the graph of the function is always below the x-axis, indicating that the function is always negative to the left of 0. Same idea, above the x-axis here, it's always positive to the right of 0. All right. We will talk about this in class. Sorry for having it there. Okay, so let's do our first sign diagram, and we can quickly do it. Let me use a straight line here. That's a little easier. We can quickly do it when we have a graph, okay? So here we go. I'm going to just draw a horizontal line, and I'm going to find out where my zeros are, and they are at -2, bonk, -2, at 1, and at 4, okay? And on this sign diagram, I'm just going to indicate whether the values of the function are positive or negative in these intervals. Because think about it. In order for a function to change from positive to negative or from negative to positive, it has to first equal 0. 0 is the gatekeeper. Okay, so to the left of -2, all of the values are below the x-axis, making them negative. From -2 to 1, they're all above the x-axis, making all of the values of the function positive. Again, from 1 to 4, below is going to be negative, and then above is positive. And there you have your sign diagram. Okay, and then for this function right here, let's mark all of our critical points where change could occur. Okay, and let's do our zeros first, and it looks we only have one 0, which actually occurs when x equals 0. Okay, but then we have an asymptote here, and that's where things can change as well, because you jump the asymptote, and it could go from a positive function to a negative as it does here. So we also have to think of an asymptote as one of our critical points, and notice I made it dashed. Like that, and that asymptote occurs at -2, and that's where this function is undefined. I don't know where that is because they don't give us the function, but that's where it's undefined. And then it's also undefined here when x is equal to 3, so I'll put a little dashed line there and put a 3. And so my sign diagram, to the right of this asymptote, all of it is below, indicating negative. Between 0 and 3, it's all above, indicating positive. And then negative between 0 and -2, and then positive to the left of -2. Okay. Okay, so it's not always, it's not ever or hardly ever going to be a graph where we need to make a sign diagram, because usually what we're going to do is use a sign diagram to help us graph. So what if you just have a function here? Draw a sign diagram for this. I wish it said f of x on there, but it's okay. We're good. So the first thing we need to do is find the zeros of this. And so we set it equal to 0. And I think we can clearly see that x is equal to -3 and x is equal to 1. So my sign diagram, my critical points are going to be -3 and +1. And so what I can do is use any point within the intervals or in the intervals to test to see if the function is going to be positive or negative. If I can, I always like to start with 0. 0 is in the interval from -3 to 1. So what do I do with that 0? Well, here's my test point. Is x equals 0, and that's for this interval right here. And so I replace it in the original function, so that would be 0 plus 3 times 0 minus 1. So that's really 0 plus 3 is 3, 0 minus 1 is -1, 3 times -1 is -3, and I really don't even care about the number part, I just care about the sign. Since it is negative, all values in this interval are going to be negative. Okay? And then now I'll choose something to the right of 1. Let's say I don't x equals 2, make my life easier. So 2 plus 3 is going to be positive. 2 minus 1 is going to be positive. And I know that's equal to 5 times 1 is 5, but all I really care about is that the result is positive, because that means everything to the right of 1 is positive. And so my last test point, x equals, let's do -4. So that would be -4 plus 3 times -4 minus 1, right? So -4 plus 3 is a negative, and a -4 minus 1 is a negative, and a negative times a negative is a positive. So I have a positive here. And just to hammer this home, I went ahead and graphed these functions. If you look, I have x plus 3 times x minus 1 right here, just like it is here. Okay, just like it is here. And notice that to the left of -3, well, here are my zeros. We got them to be -3 and 1. That corresponds to here and here. And to the left of -3, all values of the function are positive above the x-axis. Between -3 and 1, all of the values are negative. And then just as we have it indicated here, and then to the right of 1, all of the values are positive. Okay, so that was for part A right here. Oops, sorry, part A. Let's do part B. I'll do that in blue so it's a little less confusing. And so I'm going to set this equal to 0. The 2 is not consequential. So if I set 2x plus 5 equal to 0, and I solve, then I get x equals -5/2. And here, for this one, 3 minus x equal to 0, I get x equals 3. So I'm going to make my little sign diagram. Okay, my critical points are at 3 and excuse me, -5/2. Okay. So if I can start at 0, I'm going to start with a 0. You don't have to. It's fairly simple. So my test point is x equals 0. And I'll just bring this here. 2 times 2x plus 5 times 3 minus x. Okay? So again, I don't care about the value, I care about the sign, if it's positive or if it's negative. So I can think this through if I want to. If you want to substitute in for x and figure it all out, that's fine. But take a look at this. This 2 is always going to be positive. If x is 0, then this goes away, and this term is positive. 3 minus 0 is 3, that's positive. A positive times a positive times a positive is positive, meaning I know that this interval is positive. So to the right of 3, I'll choose a test point of x equal to 4, right? So 2 is always going to be positive. 2 times 4 plus 5, that's positive, so a positive times a positive. 3 minus 4 is a negative. So an odd number of negatives, or positive, positive, negative, that's going to give me a negative value, meaning everything is negative here. And then my last test point, I'm going to use x equals negative 3. Okay, because negative 3 is to the, this is actually equal to negative 2.5. I'll put that here. Negative 5 over 2 is negative 2.5. So negative 3 is to the left. Easy test point. So let's see. 2 is positive. 2 times negative 3 is negative 6. Negative 6 plus 5 is a negative. And 3 minus a negative 3 is a positive. A positive times a negative to a times a positive is going to be negative. So that means that this function right here, to the left of negative 5 halves, is always going to be negative. In between negative 5 halves and 3, it's going to be positive. And to the right of 3, it's going to be negative. So let's take a look at its graph. I know you've been dying to. See if we got our zeros right. Yep, negative 2.5, positive 3. To the left of negative 5 halves, or negative 2.5, the graph or the function is indeed negative because it's below the x-axis. Between negative 2.5 and 3, all of it is above the x-axis. And then to the right of 3, it's below, meaning it's negative. Okay, so that'll be the end. Hope you enjoyed it. We got a couple more to go. That'll be in part 2. And with that, I am out. Human race. When the lights started down, they don't know what they heard. Set the march, play it loud.